again, surface area is going to be when we're trying to find the amount of wrapping paper, the minimum amount of wrapping paper, the minimum amount of cardboard, or in real life, how much paper we're going to need. So in general, the surface area is the sum of the areas of all the shapes that cover the surface of an object. So in the next couple of years, you'll find the surface area of any type of prism, because you could find the area of the triangle, the other triangle, and then the rectangles that connect them. You could find the surface area of any type of pyramid, that one base plus the area of all the triangles, and so on. We could also find surface area of non-polyhedron, like cylinders, because you're going to have a circle here and a circle there and a rectangle that would wrap around it. But this year, we're going to do the rectangular prism. So for a rectangular prism, all 6 faces are rectangles. So you could add each face individually. Or you could add the area of each face. Individually. And again, the order is so flexible, but just to show you a sample, over here I wrote you could do length times width, but you could, and that would be like the top in the model that we did. Width times height would be the front, and length times height would be the side. And then when you do length times width again, now it's getting the back, or the bottom rather. The width times height is getting the back, and then the length times height is getting the other side. But it's so flexible, you don't have to do it in that specific order. But some people just like to go, okay, I'm going to do the L times H, and I'm going to do the W times H, and I'm going to do the L times W. I think they sort of like to have an idea of the way they're going to pair it up. And whatever order is fine, as long as you don't miss any of the faces. Another option is to find 3 pairs of opposite faces and double the area of one in each pair, and then you would add them. So the sample order here again is totally flexible, but I would take 2 of the length times widths and 2 of the width times height and 2 of the length times height. And under there you can see it's because you're finding the top and the bottom. You're finding the front and the back, and the side and the other side. So a lot of times when I'm actually doing the work, I just pair things up, and then I go, okay, now I'm going to double it and double that and double that, and I'll add them all together to find all 6 of them. And the other possible shortcut where you can use some doubling strategy would be to add the areas of 3 unique faces. It says unique faces, but in reality, if you have a square prism instead of rectangular prism, more than 2 are going to be unique. So we would have the 4 rectangles would all be alike, because we have a square, and then we have 4 rectangles that are all congruent. So the 3 unique faces, meaning of the whole idea of top and front being one idea, and the side and bottom being one unique face, and then the back, the side and other side being a face. I don't know if I said that right. Top and bottom, front and back, side and other side. Got to make sure you're getting all 3 of those parts. And double the sum to take care of opposite faces. So when we went through looking at that box, first someone told us to find the top and then the front and then the side or something like that. And then we could have just added those up and gone, now to get the other 3, we're just going to double it. So you're going to try this example. Find the surface area of the following rectangular prism. Does everyone have all the words filled in for the notes? Because I've got to clear the ink and scroll it down so we can do this example. So find the surface area of the following rectangular prism. We're going to write it nice and formally down here, but what I really usually do do is I just go, okay, 3 times 10 is 30, 4 times 10 is 40. And then I go, now what other pair can I make? I did the easy ones first, I love times 10. What other pair am I missing when I try to pair up my dimensions?
3 times 4.
3 times 4. So when I'm actually doing the computations of finding surface area, a lot of times I just pair up 2 of them, pair up another 2, and then go, okay, what's the other one I'm missing? Because I'm always confused about what I'm missing. And I go, okay, good. Now I have 3 of my 6 faces. Now I have that whole, am I going to add these and then double it? Or am I going to double each one and then add them together? Or am I going to just write the 30, 40, and 12 again and just add up all 6 individually? I just have to keep in mind that just then I only found 3 of the 6 faces. Now for the formal write-up, I'm going to write this whole idea of a formula. So 2 of the length times width, I'm going to have 2 of the length times height, and I'm going to have 2 of the width times height. So in this particular case, 2 of the 10 times 3, and 2 of the 10 times 4, and 2 of the 3 times 4. So I'm just formally writing down in a formula, so you're going to see this on one of the sides of your homework, where they have it as a formula like this. So I have 2 faces that are each 30, and I have 2 faces that are each 40, and I have 2 faces that are each 12. That means I'm going to have 60, 80, and 24 that I have to combine. Oh, geez. And I'm trying not to take on too much at one time. Sometimes I just line them up and I add them up. But this, I've got 164, and what's the units going to be? Looking at the original rectangular prism over here, what's the units going to be? How much wrapping paper would I need? What's the minimum amount of wrapping paper? 164 what?
Centimeters squared.
Centimeters squared, good. The other formula type style that you're going to see on the homework would be the idea of doubling the sum of the 3 faces. So if you could write this, maybe even sort of separate it. So if you have room, you could write down that we could instead have found these products. I cannot write anything anymore. That's it, I'm going back to bed. I'm done. Plus 10 times 4, plus the 3 times 4. So I'm going to double the sum of the 30, the 40, and the 12, which means I'm going to double 70 plus 12, or double the 82 to get the 164 centimeters squared. So like I was saying, a lot of times I don't necessarily write it in proper formula format. Instead, I find my pairings like we did up here in the blue, and then I figure out what way do I want to get all 6 of them. So I've done these computations in the formula model, but if I wanted to add these up and then double it, that would be like the green model. That would be taking my 30 plus 40 plus 12, adding them up, 8, and then doubling it to get my 164 centimeters squared. My red model over here is like taking each of these and going, okay, that means this is 60, this becomes 80, this becomes 24, adding them up. Because I've already doubled them to get that I have 2 faces, and the other 2 faces. Do you get the idea how you can show your work, how you can find your pairings? On the back side of the note, you're going to try out some problems.